Good morning to all. In today's class, I will explain finally block. In the last two classes, I already explained try and catch blocks. Okay. So now this is the third block we have. In exception handling, we have only 5 keywords. If you understand the purpose of these 5 keywords, then you can easily understand exception handling concept. Okay, so what are the 5 keywords we have in exception handling? Okay, first one is try, second catch, third finally, fourth one is throw, fifth one is throws. Okay, these are the only 5 keywords to understand exception handling concept. Okay, already I explained in depth about try and catch blocks. Again, we will see try with multiple catch blocks and nested try catch blocks, etc. But before discussing those concepts in depth, first we will complete finally block. Okay, now coming to the finally block. You know now try, catch and finally, these are the blocks. Okay, block means this open brace, closing brace means some functionality we can write in that block. Okay, block is nothing but open brace, closing brace, that is considered as in between. We can write code, no, that is called block. So each block is given one name. Try block means try followed by open brace, closing brace. So inside the try block, we will write the code. That is the code for that try block. Similarly, catch block means catch. Okay, catch is taking one parameter, that is one exception class name and the reference variable of that exception handling. That exception class we should write as a parameter to the catch block. So catch of exception class name followed by reference variable. Next, open brace, closing brace. That is the syntax of catch block. In the same way, finally block, finally, okay, immediately followed by open brace, closing brace. This is finally block syntax. Now we will see finally block in depth. So finally block is the block which is always executed, whether the exception is raised or not and exception is handled or not. So always finally block is executed. So this is the first important point to remember for finally block. It is the block which is always executed, whether exception is raised or not and exception is handled or not. Okay, we will see in the programs. Next, inside finally block, we will always write the cleanup code. Okay, in garbage collection, okay, we have used cleanup code or we have written cleanup code in finalize method now. So before going to destroy the object by garbage collector, first garbage collector will execute the finally, not finally, will execute the finalize method of that class. Okay, inside the finalize method, we will write the cleanup code in garbage collection. In the same way, inside finally block in exception handling, we will write the cleanup code to close the connections which are opened. Okay, only in the finally block, we will write the cleanup code, that is nothing but closing the connections. So it is optional only. If you want to write finally block. When you write finally block, if you already open any database connectivity or network connectivity, it is your duty to close those connectivities, no, which are opened by you only, no. That's why in any program, if you open any network connections or database connections, in the same program, you have to write the closing also. You have to close the connections also. Okay, for that purpose, in exception handling programs, to write the cleanup code, we use the finally block. So the purpose of finally block is to write the cleanup code, that is to close the database connectivities, network connectivities, like that. So this is always executed, that is first point, and inside the finally block we will write cleanup code. So finally block is optional. You see if you see the previous programs, we have written programs using default exception handling and customized exception handling. No, there we have not used finally block. No, in the previous programs we have used only try block and catch blocks. We have not used finally block because finally block is optional. Okay, it is not must. If you open any database connectivity or network connectivity in exception handling programs, in those cases only, right, in addition to try and catch blocks, also include finally block. Otherwise, it is not required always. That's why it is optional. Next. So this is very important question for exam point of view. So what is the difference between finalize method, finally block and final? Okay, so you know final is a keyword. Already explained final keyword in depth. So finally block is in exception handling we will study. Next, already we studied finalize method in garbage collection. So try to understand the differences between these three concepts. So you know regarding final methods cannot be overridden, final classes cannot be subclassed, final variables cannot be modified. You can write programs using these three concepts. Like that finally block, now I will explain the programs on finally block in exception handling. Already explained finalize method in garbage collection. You know how to write the program, okay, in garbage collection using finalize method. The purpose of these two is only to close the connections which are opened in the program. Purpose is same, but this method we will use in garbage collection programs, but this block we will use in exception handling programs. That's it. Next, finally block is always associated with the try catch blocks. You can't write finally block independently. It must be associated with try catch blocks. That is one more important point regarding finally block. Next, we will see try catch and finally blocks. So try block already explained. Inside the try block we will write the risky code. Inside the catch block we will write the handling code, because here you will get one exception in try block. That exception is handled in the catch block using matching catch block. Writing the catch block it does not mean we are handling the exception. So writing the matching catch block, which is matched to the exception raised in the try block, that is most important. Means if you write the matching catch block, means you are handling the exception. Suppose here exception is raised for arithmetic exception. If you write the catch block inside this parenthesis, if you write null pointer exception, means arithmetic exception is not matched with this null point exception, means it is not matched, means here you are not handling the exception. If you won't handle the exception, what will happen? Already explained in the morning class. Default exception handling means JVM will handle that exception if this exception is not matched with this parameter of the catch block. So in this case also it is nothing but okay, or it comes under default exception handling. So don't think that writing try catch blocks means we are handling the exception. It is not like that. If you won't write the matching catch block for the exception raised in try block, it means that you are not handling the exception. Means if you won't handle the exception, then who will handle that exception? Okay, JVM will handle that exception using default exception handling procedure. That's why remember this point, try catch, regarding try catch. Next, finally block. Inside the finally block we will write only cleanup code. Here we will write only cleanup code, is nothing but closing the connections. Okay, so that is if any file is opened or to close that file, we use finally block. Why we should write the cleanup code in the finally block, I will explain now. So this is the syntax for try catch finally. Try followed by open brace closing brace means it is try block. Inside try block we will write only risky code, and the length of the try block is as minimum as possible or as less as possible. Don't write too many statements in the try block, because before try block you can write any statements now. That's why only write the risky code only in the try block. Next, inside between try and catch, don't write any statements. If you write any statements between try and catch, definitely you will get compile time error. Next, catch is always taking one parameter. This parameter is nothing but exception class object or reference variable. Here we will write class name, here we will write variable. Okay. Next, inside catch block, we will write the handling code. Means whatever exception which is raised inside the try block, that is handled in the catch block. That is the purpose of catch block. Suppose here, see, writing catch block is also not a must. We can write only try block. Suppose if there is no exception in the try block, there is no need to write the catch block, no. So only simple try also we can write. No problem. Suppose if you write a try and exception is raised also, no problem if you won't write catch. Because here exception is raised, then in this case, who will handle that exception? JVM will handle that exception. That's it. That's why default exception handling procedure is very, very important. Unless you understand that procedure, you can't follow the programs. Because no need, writing the catch block is not a must. Only we will write simple try. So inside try, if you won't write any risky code, okay, it will be executed as usual normally. But inside try block, if any exception or error is there, if you won't write catch block, then JVM will handle that exception, no problem. But abnormal termination occurs. See, whenever JVM this handle that exception, always abnormal termination only, remember. It is not a graceful termination. Whenever you handle your exception, then that is called graceful termination. Now this is regarding try catch finally. Suppose if you don't want to write any cleanup code, because if you don't want to open any database connectivity or file or anything, then finally block you need not write. So this is also optional. This catch block is also optional. Only simple try we can write, or we can write try with matching catch block. This also we can write, or we can write all the three. So these are the try, catch and finally blocks, which can be written in exception handling programs only. Next, why we should write cleanup code in the finally block only? Some reason should be there, no? Okay. So what is the reason why we should write cleanup code only in the try block is here I will explain. So it is never recommended to write the cleanup code in try and catch blocks. Never recommended. There is no guarantee. Why? Because there is no guarantee that the statements of try block or catch block will be executed if you write the cleanup code in try and catch blocks. Here put catch also. Okay. So there is no guarantee that the statements of try block or catch block will be executed. That's why don't write. Why I will explain later in the programs. So that's why don't write cleanup code in the try and catch blocks. Okay. Next, if an exception is not raised in try block, okay, no need to write always exception in try block. Already explained. We can write simple try. Simple try means it is not for it is like part of the main method only. So if you write only try without exception, also correct. That is called simple try. Means without catch block, we are writing only try block. So in that try block, exception may be raised or may not be raised. Suppose exception is raised, then what will happen? JVM will handle that exception because you have not written the matching catch block, no? That's why inside the try block, if exception is raised and you have not written the corresponding matching catch block, in that case, JVM will use the default exception handling procedure to give the output for that program. You can understand all these points. So if your exception is not raised means no problem. Okay. We need not worry about that one, or JVM need not worry about that one. If exception is not raised in try block. If exception is raised in the try block, either the programmer has to handle using the matching catch block, or the JVM will handle if the programmer has not handled. That's it. Okay, either the programmer or the JVM. You remember these 2 points enough. No, next, if an exception is not raised, okay, in try block, okay, then the catch block will not get executed. Is it right? Yes. No need to write that exception always in the try block. Suppose if we have not written any error in the try block, then how the catch block will be executed? Only if exception is raised in the try block. So from that statement, it will search for the matching catch block. If exception is not raised, the try block, try catch and finally blocks are part of main method only. It is like normal code only. So if exception is not raised in the try block, only the statements of try blocks are executed as part of main method and the rest of the program is executed, but catch block will not be executed. Why? Because if exception is raised in the try block, then only the corresponding matching catch block will be executed. Otherwise, see this point. If exception is not raised in the try block, then catch block will not get executed. That's why. So if here, don't write the cleanup code in the catch block, because catch block is not always getting executed. Only if exception is raised in the try block, then only the corresponding matching catch block will be executed. But for one try, we can write any number of catch blocks. That's why try with multiple catch blocks. Okay, for one try we can write multiple catch blocks. That's why it is not recommended to write the cleanup code either in the catch block or try block. Okay. Next. Now we will see the programs on try catch finally. So regarding finally, I am repeating once again the points. Finally block is the block which is always executed whether exception is raised or not, or handled or not. Okay. Next, it is never recommended to write the cleanup code in the try catch blocks, and it is always recommended to write the cleanup code in the finally block, because whether exception is raised or not, handled or not, finally block is always executed. Okay, that is the reason why we should write the cleanup code only in the finally block. Once you understand these concepts, programs are very easy only. Simple programs only you write in the exam, but you should be able to explain the concept clearly in that program. See, Java is only concept oriented programming language. Okay, first for any concept you take, first understand that concept in depth. After that, try to write at least 2 or 3 programs using that concept by taking different examples. No need to take the same example also. You can take your own examples, because it is not, we are not writing the logic, no. Only concept I am trying to explain in each and every program. That's why how best you can explain the concept with your program. Okay, please concentrate on that only. Don't by heart the programs in Java. All are concepts only. Concept means finalize method is one concept, finally block is one concept, abstract class is one concept, interface is one concept, final keyword is one concept, static keyword, all these are concepts. Okay, first write all the concepts which are there in the Java programming language in your syllabus. After that, take one concept and understand that concept thoroughly in all the cases. After that, try to write your own programs using that concept. Constructor is one concept. Constructor means you should write types of constructors. That is compiler generated constructor, next user defined OR constructor, user defined parameterized constructor. And for each of these 3 types of constructors, try to write at least 2 or 3 programs. You can write any number of programs, your own programs only, own examples. All these are real-time examples. Okay, you need not by heart. Easy Java programming language is the easiest programming language if you understand the concepts. Next, we will write one program on using try, catch, and finally blocks. Okay. Next, class test. Inside the class test, I have written main method. So inside the main method, I am writing try, catch, finally. What does it mean? Try, catch, finally blocks are part of main method only. Okay. Next. So inside the main method, I have written try, catch, finally. See, inside try I have written only system.out.println try. Inside catch, it is taking one parameter. No, I have taken arithmetic exception AE. Inside catch block here system.out.println. It is not catch. System.out.println catch. Finally, this is the finally block. System.out.println finally. See, if you won't write catch block, only we can write the programs with try and finally. That is also true. We can write the programs only with try catch, or only with try and finally without catch, or we can write the programs with try catch finally, or we can write the programs with try or try with multiple catches and then finally. All these are correct. You can write as you like, but concept is that between try and catch don't write anything, and between catch and finally don't write anything. And one more point is, you can't write catch block independently without try, and you can't write finally block independently without try. Either you can write combination C, either you can write try catch, or we can write try finally, or we can write only try. This is also correct. But without try don't write catch, or without try don't write finally. All these points are important. Okay, and there should not be any statements between try and catch blocks, and similarly there should not be any statements between catch and finally blocks. Okay, only try finally correct, only try catch also correct, all the three also correct. Here I have taken all the three. We will see the execution. Here first JVM will execute the main method. So as part of main method I have taken try catch and finally blocks. First try. Try means system.out.println try. See, if you see this program here, you can understand that no need to write the error always in try block. Okay, so here exception is not raised in the try block. So exception may be raised in the try block or may not be raised in the try block. Both are 100% correct. Okay. Now here exception is not raised in the try block, but because here there is only one statement which prints only try or try block. Okay. First it will execute main method, then it will execute try block, that is try. Next after that, will it go to the catch block or not? It will not go to the catch block. Why? Because when exception is raised in the try block, then only from that statement it will search for the matching catch block and it will execute the matching catch block. But here exception is not raised. Then what is the need to execute this catch block? That's why immediately from the try it will go to the finally block. This catch block will not get executed. That's why after try finally block will be executed, and the output for this program is try followed by finally. That's it. See, try finally. Catch block is not executed because exception is not raised in the try block. Okay. Next we will see. Next program 2. Here I have written in a different way. So here if you see this program, inside the try block exception is raised. Whereas in the previous program exception is not raised in the try block. That's why catch block is not executed in the previous program. But here exception is raised in the try block. That's why the matching catch block will get executed. So first main method is executed. So it will print try followed by 10/0 means error. So from this statement the JVM will go to the matching catch block. This is the matching catch block for this error or exception. So the runtime errors are called exceptions. Next, so from this statement it will go to this one and it will find the matching catch block and it will execute this catch block. Followed by finally block is always executed whether exception is raised in the try block or not, or exception is handled or not in the catch block. So that is the importance of finally block. So finally block is the block which is always executed whether exception is raised or not in the try block or handled or not in the catch block. That's it. So here the output for this is try, catch, and then finally. See, in the previous program the output is try finally. but here try catch finally. Next program I will explain one more. Next here, exception is raised, but is it handled? No. Why? Because in the try block it is arithmetic exception. Always JVM will search for the matching catch block. Here arithmetic exception is raised, but here we have taken the catch block with null pointer exception. Means it is not the matching catch block. That's why repeatedly I am explaining the same thing. Writing the catch block is not important. Means it does not mean we are handling the exception, but writing the matching catch block is very, very important. Here a arithmetic exception is raised, but we have written null pointer exception. That's why it is not the matching catch block. So, but even though the exception is not handled in this program, but finally block is executed. Now you can understand more clearly. Finally block is the block which is always executed, whether exception is raised or not, or handled or not. Next, if we here this is abnormal termination, no? Here we are handling the exception, or the JVM is handling the exception. Okay. Now here in this program, JVM is handling the exception. In the previous program, programmer is handling the exception, because inside this for this exception there is a matching catch block. Means programmer is handling this exception. It is nothing but customized exception handling. But if you see, customized exception handling means graceful termination. After finally block, if you write any code, that will also be executed. After finally block, we can write any number of statements. Those statements will get executed in case of customized exception handling. That's why try catch finally. After that, if you write any statements after finally block, those will be executed and you will get the output here. But this program is customized exception handling, no? Because we have written the matching catch block, means the programmer is handling the exception. Compare these two programs. Here this is a program on default exception handling. Even though we have written catch block, but it is not the matching catch block. That's why the programmer is not handling the exception. So in this case, JVM will handle the exception. Whenever JVM handles the exception, always it is abnormal termination, not graceful termination. What is the meaning of abnormal termination is, see from this statement, first it will go to the finally block, because the finally block is always executed whether the exception is handled or not. Here this exception is not handled. Even though the exception is not handled, finally block is the block which is always executed. That's why first try, then finally, then from this abnormal termination occurs. Abnormal termination means after finally block, if you write any code, it will not get executed. Why? Because it is abnormal termination. Here in this program, JVM is handling this exception. Whenever JVM handles the exception, means it is always abnormal termination. That's why see the importance of finally block. Even though this exception is even though the exception is not handled by the program, in that case also finally block is executed. After that only abnormal termination occurs. Means the statements which are followed by the finally block will not get executed. If you understand these two programs, the difference between these two programs, you can also understand the difference between default exception handling and customized exception handling, and also the importance of finally block. Okay. So here try, and this is finally, and here you will get the morning I explained no default exception handling. That object description you will get, means the object information is printed as output. Next. So same. Next, one more important point is here you may get one doubt. When the finally block is not executed, we are saying always finally block is executed whether you handle the exception or not, or whether the exception is raised or not, or handled or not. In all the four cases, always finally block is executed. But when the finally block is not executed, there are only two cases where finally block is not executed. So what are the two cases? I will explain. if you write written statement in try block. Okay, if you write written statement in try block, then finally block will not be executed. And one more is if you write system.exit of 0 in try block, in this case also the finally block is not executed. So these are the only two cases where finally block is not executed. We try in the lab. So inside try block I have written system.exit of 0 means it will come out of the main method. When it comes out of the main method using this statement, how the finally block will be executed, that's why finally block will not executed. If you write written statement also in try block, the finally block will not be executed. So this is about, here output is only try. This is about try, catch and finally. Next. Here next concept is if exception is raised in try, catch and finally blocks. Means in try block, in the previous programs, only exception is raised in the try block only, no? In the same way, exception may be raised in the catch and finally block also, no? That's why here I have written a program where exception is raised in all the three blocks, that is try, catch and finally. So this program, so test inside the main method, I have written try block. This is one exception. Okay, and inside the catch block also I have written one exception, and inside the finally block also I have written one exception. This is string index out of bounds exception. Okay, no, not string, null pointer exception. No, it is not string, null pointer exception. You know null pointer exception, only reference variable is assigned null. It is not pointing to object, but we are trying to access the members of that string class. That's why it is null pointer exception. And here it is array index out of bounds exception, because we have created an array and we are accessing the index values out of the range. Range means 0 to 3, but we are 0 to 2, because 3 means 0 to 2, but we are accessing out of bounds, out of range. That's why array index out of bounds. So here if you see this program, it is a program on exception handling. Here in all the three blocks, exception is raised. Exception is raised. Okay. Now this is what arithmetic exception. No? From this try block, it will go to the matching catch block. This is the matching catch block. Again, exception is raised in the catch block. Okay. This is null pointer exception. Even whether the exception is raised or not, or handled or not, always finally block will be executed. No? That's why here this is the matching catch block. That's why from this it will go to this catch block and it will execute this one. Whether exception is raised or not, handled or not, finally block is executed. No? So this is executed. Now what will be the output for this program? Because here all the three blocks are executed. Try block means this is arithmetic exception. That's why it will go to the matching catch block and it will execute this one catch block also. So whether exception is raised or not, handled or not, always finally block is executed. That's why this is also executed. Now in this case, what will be the output? This is a problem. No? So here the answer for this is, it will handle only one exception at a time. In one program, here it is default exception handler. Okay, in all the, because here up to this, okay, we have handled. After that, in the finally block also exception is raised. No? So in the try block, exception is raised. So by writing the matching catch block up to this, okay, means this is customized exception handling. Okay, I will agree. But here again exception is raised in the catch block. Who will handle this exception? Inside the catch block. Again, in the finally block also exception is raised. Who will handle that exception? Only I am handling, programmer is handling the exception which is raised in the try block by writing the matching catch block. That's it. Up to this only the programmer can do. But inside the catch block, if exception is raised, programmer cannot do anything. Inside the finally block, exception is raised, programmer cannot do anything. That's why this is a program on again default exception handling. So in default exception handling, as per the procedure of default exception handling, default exception handler will handle, okay, only one exception at a time. That is the last raised exception. So because of this reason, what will be the output? What is the last raised exception? This is the last raised exception. No? So you'll get the output as array index out of bounds exception. And the object information is displayed by the default exception handler, which is part of JVM as per the procedure of default exception handling. Okay, that's why try to understand the default exception handling procedure. Unless you understand the default exception handling procedure, you can't understand the outputs of all these programs. Okay, so that's the default exception handler handles the last raised exception. That's why this is the last raised exception. That's why the output is array index out of bounds exception. Next. So nested try catch blocks means inside one try, again we can write try catch block. So this concept is nothing but nested try catch blocks. Again I am repeating, inside the try block we can write try catch and finally. Okay, now I will explain the program. So syntax is like this. So inside the try block, here I am writing try catch and finally blocks inside try block. This is the open and closing brace of this try block. So inside this try block, I am writing try catch and finally blocks. This is catch block. This is finally block corresponding to this try. Indentation is important here. Okay. So that's why here we have two tries. No, that's why you can say this is outer try and this is inner try. Okay. So with respect to outer try, so this is outer try, outer catch. Okay, and outer finally. Outer try, outer catch, and outer finally. If you take this one, which is there inside the try block, this is inner try, inner catch, and inner finally. Okay, so with respect to these, we can discuss nested try, catch, finally blocks. You know nested for loops, no? Like that. Now inside the try block, I can write try, catch, finally blocks. Okay. Now, how do we write the programs using nested try, catch, finally blocks? We will see. So this is the syntax. Understand. Try to understand. This is outer try. This is outer catch, outer finally, and inside try we have written this. No, that's why this is called inner try, inner catch, inner finally. Next we will see programs. Only these 2 points are very important. So if an exception is raised in the outer try, then outer catch can only handle it. Understand this point. So if an exception is raised in the outer try, who will handle that exception which is raised in the outer try is, the only answer is outer catch. Next, if an exception is raised in the inner try, then who will handle that exception which is raised in the inner try is, there are two ways. Okay, either by the inner catch or the outer catch also can handle that exception. If you understand these 2 points, you can easily understand the program on nested try catch blocks. Okay, so if an exception is raised in the outer try, there is only one way to handle that exception, that is through outer catch. But if an exception is raised in the inner try, there are two ways to handle that exception, that is either using inner catch or using outer catch. First priority will be given to inner catch only, because the exception is raised in the inner try, no? That's why priority will be given first to inner catch. Suppose if inner catch is not handling that exception which is raised in the inner try, then it will verify or it will check in the outer catch. Okay, so these 2 points are very important. So using these 2 points, we will write the program. Here I have written clearly, first priority is given to inner catch if exception is raised in the inner catch. If inner catch is not matched, then only it will use outer catch. Now this is the program on nested try catch blocks. See here, class test inside the main method. First I will write a try block. This is outer try. So the code which is there in the outer try is first system.out.println outer try and system.out.println 10/0. These two statements are part of outer try as well as these try catch, inner try catch finally. This is also part of outer try. Understand? So outer try contains the code. Okay, these two statements as well as this also. This entire code, that is inner try, inner catch, inner finally, also part of outer try. So outer try consists of the entire code. We will see. First, execution starts from the main method, then it will execute this outer try. Now we will see system.out.println, it will be printed as output. After that, system.out.println 10 by 0. 10 by 0 means again arithmetic exception is raised, no? So from this point, the JVM will go to the outer catch only, no? Because it will not execute these statements. Already explained, the statements which are followed by the exception statement will not get executed. Here exception is raised, means this part will not get executed. So for this, it will check the matching exception or matching catch block as outer catch block only. Already explained. Okay, if exception is raised in the outer try, if exception is raised in the outer try, then only outer catch can only handle it, because after this statement, it will not execute these statements. Already explained. Whenever exception is raised in the try block, immediately from that statement, it will come out of that try block without executing the statements which are followed that exception statement. Okay, that's why, because of that reason, this will not get executed. So from that statement, it will come out of the outer try, and it will verify, it will find the, or it will search for the outer catch. So is it the outer catch? Yes. So is it the matching catch block? Yes, because 10 by 0 is arithmetic exception, no? That's why outer catch. See, here I am writing a arithmetic exception only to explain the concept. Why? Because it is easy to understand. So in place of arithmetic exception, you can take any other exception. Concept is same. So in place of arithmetic exception, you can take null point exception, array index out of bounds, string index out of bounds exception, class cached exception, anything you can take. Okay, but arithmetic exception is easy to explain. That's why I have taken arithmetic exception. Okay, for better understanding. Okay, otherwise you can take any other exception in place of arithmetic exception. So here exception is raised in the outer try, no? That's why only outer catch, matching outer catch will be executed. So this is the matching outer catch. That's why outer catch. After that, anyway, finally block will be executed, no? Whether exception is raised or not, or handled or not. That's why outer finally. So what will be the output for this program? Here inside outer try, this will be executed, and this will also, from this, it will go to the matching catch block, outer catch block. That's why outer catch. Again, anyway, finally block is executed. That's why the output for this is outer try, outer catch, and outer finally. So in this program, you can understand that outer try can make use of only outer catch. It cannot make use of inner catch. You remember this statement. But whereas inner try can make use of outer try as well as inner try. But first priority is given to inner catch only. If it is not matched, then it will go and search for outer catch. Okay. For that, I will explain this program. We will see what is this program. So this is outer try. Okay, system.out.println. So inside outer try, we have written try, catch, and finally. Next, again this inner try, you can write again try, catch, and finally. This is nested, no? No need to write only inside try, only one try, catch block. Again inside this try, I can write again try, catch, and finally. Like that, any number of times you can write. That's why it is nested try, catch. Because in the inner try also, we can write try, catch, finally. We can say inner try. Okay, like that we can extend the program. Now I have taken only inside the try block, I have taken only one time, that is try catch block. Now we will see where the exception is raised, in the inner try or outer try. Okay, here in the outer try, see exception is not raised. In the previous program, exception is raised in the outer try. Is it inner try? Yes, because it is there in the outer try. That's why it is called inner try. See, in the inner try, exception is raised. Okay, so who will handle this exception which is raised in the inner try is first inner catch. JVM will search for the inner matching inner catch. If matching inner catch is not available, then only it will search for the outer catch. Okay, this is the rule, it follows JVM. Now system.out.println 10 by 0. So from this, first JVM will go to the inner catch only. Is it the inner catch? This is inner try, no? The corresponding one is, this is the inner catch. First it will check whether it is matching inner catch or not. This is arithmetic exception. This is also arithmetic, means matching, means it will execute this one. Anyway, this is what output, we will see the output sequence. First outer try, then inner try. Next from this it will go to the matching the inner catch block, that is inner catch. Next after that finally block is always executed, no? That's why inner finally. Next, so outer try is completed, its execution. Next, will it be executed outer catch? No. See here also it is a matching, okay, it is a matching class for 10 by 0. But here first it will give the priority to the inner catch, See here I have written, in the inner catch I have written arithmetic exception, that is matching. In the outer catch also I have written arithmetic exception, which is also matched to that exception, which is raised in the inner catch, inner try. But as per the rule, first it will check only inner catch. If it is matched, it will execute only inner catch. It will not execute outer catch. Suppose here if you write a null pointer exception, then inner catch is not matched, then it will go and check the outer catch. If it is matched, if outer catch is matched, it will execute. If outer catch is not matched and inner catch is also not matched, then in that case it is abnormal termination, and this is done by JVM only using default exception handler. So try to understand the concept. So for this program, what will be the output? Outer try, then inner try, then inner catch, then inner finally. Next, this will not be executed, outer catch, and in this finally block also executed, that is outer finally. That's why finally block is always executed. See, if you see, inner finally executed and outer finally executed. Which is not executed in this program is outer catch, because inner catch is matched for the inner try exception. That's why only inner catch is executed, outer catch is not at all executed. That's why here you cannot see outer catch. Okay, outer try, inner catch, inner finally, and outer finally. And now what I will do is I will write one inner catch block which is not matched to the exception which is raised in the inner try. Same program I will modify. Try, outer try. So here exception same program, but I have written here. Okay, this inner catch block is not matched with the exception raised in the inner try block. This is arithmetic exception, this is null pointer exception. That's why this catch block is not executed. In this case, what it will do is, the JVM will search for the outer catches. More than one catch also we can write. One try with multiple catches, correct. So is it outer catch? Yes. Is it matching? Yes. Means it will execute. So what will be the output? See, first you will see the output order. Outer try. Okay. See, outer try. Next, inner try. Next, inner catch is not matched, means it is not executed. Next, whether exception is raised or not, handled or not. Then finally block is executed. That's why inner finally is executed. So with this outer try is completed. After completion of the outer try, it will verify the outer catches. Any number of catch blocks we can write. So it will verify the outer catches whether matching exception class is there or not. Yes, it is there. So it is outer catch. So this the exception which is raised inside the inner try is handled in the outer catch. This is one more important point to remember. Okay. Now what will be the output? Inner finally, up to inner finally. Okay. Next, outer catch, then outer finally. That's why if you see the output, outer try, inner finally, outer catch. This is the outer catch which is executed. That's why outer finally. Here only thing is inner catch is not executed. In the previous program, outer catch is not executed. In this program, inner catch is not executed. Next throw, tomorrow, next class we will see throw and throws. Before that, I will explain try with multiple catches. Next, try with multiple catch blocks. So one try can have any number of catch blocks. Already explained, no? write only one try, and after that write any number of catch blocks. In each catch block, we will write one exception class. So while writing multiple catch blocks, the order is important. We have so many exception classes, null point exception, array index, out of bounds exception, arithmetic exception, and I will explain the hierarchy of exception. Okay. Now here the order is important. Now I will explain which order we have to follow while writing multiple catch blocks. Okay, in a program. Next character order is child to parent. So you don't know what is child, what is parent. Now I will explain this point with respect to exception hierarchy. Okay, one hierarchy is there for exception classes. That is with respect to inheritance only. You know, inheritance means superclass, subclass, no? And multi-level inheritance already you know, no? Okay. So like that here also with respect to exception classes, that is predefined exception classes, we have one hierarchy that is called predefined exception hierarchy. So if you understand this predefined exception hierarchy, then only we can understand this order, which order we have to follow while writing multiple catch blocks. And the answer for this is child to parent. Child means subclass, parent means superclass, means inheritance is important. While writing multiple catch blocks, we should know the inheritance among the exception classes in the exception hierarchy. So coming to the predefined exception hierarchy, throwable is the root class for the exception hierarchy. So for all the exception classes, throwable is the root class. Next, on the top of the throwable, object class is there. Because you know, in Java, each and every class, whether it is user-defined class or predefined class, it extends object class. That's why even though throwable is the root class for the entire exception hierarchy, but still throwable is a subclass of object class. Because every class in Java must extend object class. Okay, that's why first object, then throwable. Next, the child classes of throwable are only two. They are exception and error. E capital here. Because exception is a class, error is a class. All these are classes only in Java. Okay, all these are predefined classes. User-defined classes means we are writing our own classes, no, like employee, box, student, bank account, like that we can write. Okay, so here this is predefined exception hierarchy. In this, first the important points are: first, object is the superclass. Next, throwable is the subclass of object class. Next, under throwable we have two subclasses. They are exception and error. These two are also predefined classes. For these two subclasses, there is a superclass throwable. Because in Java, any number of classes can extend the same class, but one class cannot extend more than one class. Means multiple inheritance is not supported by Java. But this is correct only, no? Exception, class exception extends throwable. Class error extends throwable. Correct. Okay. Now, the two child classes of throwable are exception and error. Okay. Next. So, what is the difference between exception and error? Exception is created by the programmer and it is recoverable. But error is not created by the programmer and not recoverable. So this exception means we are writing the program now using 10 by 0, or null point exception means we are not pointing to the reference variable is not pointing to the object. Without pointing to the object, we are accessing the members of that object. All these are the programmer is writing. Okay. Similarly, array index. We have created an array and we are trying to access the index value which is out of the range. So all these the programmers are writing. That's why these are called exceptions which are created by the programmer only through program. That's why example is exception means arithmetic exception. But if you take error, these errors are not created by the programmers and not recoverable. Memory problems. So memory problems you can't rectify, no? That's why error, exception and error are two subclasses of throwable. Now this is the exception hierarchy. This is very, very important. Go to take complete reference book, and in that, in exception handling chapter, complete exception hierarchy is given. Okay, now I will explain. Then after this, if you see the textbook, you can easily follow this exception hierarchy. Now object is the superclass. and throwable is the subclass of object class. Again, throwable is divided into means this part, this by this is these are the two subclasses of throwable. No, that's why exception error. Next, under exception classes. Under exception class, again exception is just a super class for all these classes. So what are all these classes? Under exception we have runtime exception and interrupted exception, IO exception, servlet exception. All these are subclasses of the exception class. And exception, see the hierarchy, it is multi-level inheritance only. If you take this path, is it multi-level? Yes. Throwable is a subclass of object. Again, exception is a subclass of throwable. Again, runtime exception is a subclass of exception. Like that, it is multi-level inheritance. Okay, like hierarchical inheritance. Okay, you know hierarchical inheritance. No, this full figure is for hierarchical inheritance. Now, under exception means exception is the superclass for all these classes. Means these are the subclasses and for the superclass exception. So this is very, very important. Okay. So under exception we have a runtime exception. This is very, very important. So under runtime exception, again already we discussed. Under runtime exception we have arithmetic exception, null pointer exception, class cached exception, index out of bounds exception. Again, see, under index out of bounds exception we have array index out of bounds exception, string index out of bounds exception. So this is the hierarchy. Next, illegal argument exception. Again, under illegal argument exception, the subclass is number format exception. Next, illegal state exception. Like that, we have under illegal state exception, threat state exception, all these. Okay, this entire hierarchy we have to remember. Next, so under exception, we have a runtime exception is one subclass. Similarly, the remaining subclasses are interrupted exception. Here, right, interrupted exception. Next, IO exception and servlet exception. So under IO exception, we have EOF means end of file exception, file not found exception, interrupted IO exception. All these are there. Okay, like that we have to remember this hierarchy. See here, error is one more subclass of throwable. No, under error we have virtual memory error, assertion error. Okay, under virtual memory again we have out of memory error. Okay, here error is there. Exception means at the end file not found exception. Here like that it must be suffixed with error, out of memory error, assertion error, virtual memory error. Like that here end of file exception. Okay, it must be suffixed with exception. Here it must be suffixed with error. So this is the hierarchy. In this hierarchy, the important points are now coming to exceptions are of two types: checked exceptions and unchecked exceptions. So what are checked exceptions and what are unchecked exceptions, and what is the difference between checked exceptions and unchecked exceptions? This is very, very important. So if you see throwable, this is the checked exception. Next, if you see exception and error, these two are subclasses of throwable. No? Throwable is a checked exception, whereas this is exception. No, exception is a checked exception, whereas error is unchecked exception. I will explain the difference in the next class, but try to understand there are two types of exceptions: checked exceptions and unchecked exceptions. Throwable is a checked exception, and exception is an checked exception. Error is unchecked exception. Next, under exception means exception is a checked exception. No, under checked exception, that is exception, we have error, runtime exception is unchecked exception. See, exception is checked, and under exception we have a runtime exception, which is a subclass of this class. So again, this subclass is unchecked exception. Means runtime exception is an unchecked exception. Next, interrupted exception and IO exception and all these, and servlet exception, all these are checked exceptions. This part is checked. Again, under exception which is checked, we have a runtime exception which is unchecked, and the remaining all are checked. Next, now here you may get one doubt: how do we identify or how do we know whether it is a checked exception or unchecked exception? Here you can remember like this. Here runtime exception is which one? Unchecked exception. No, so runtime exception is unchecked exception. Under runtime exception we have these subclasses. Okay, this is all these are subclasses of runtime exception. So totally, including runtime exception and its subclasses, totally there are only 18 unchecked exceptions. If you remember all these 18 unchecked exceptions, the remaining all are checked exceptions. Because you have to identify whether your exception is checked or unchecked. Next, I will explain why we should know whether it is checked or unchecked. Compulsory we should identify. So for that, we have given one easy way, that is runtime exception. See, runtime exception and all its subclasses. Runtime exception and all its subclasses. All these are subclasses of runtime exception. Means runtime exception is the superclass and all these are subclasses of this runtime exception. So runtime exception and all its subclasses are unchecked exception. Unchecked exceptions. There are only 18 unchecked exceptions in the entire exception hierarchy. So you should remember all the 18 unchecked exceptions. If you remember all these 18 unchecked exceptions, the remaining all are checked only. So try to see the hierarchy figure in the complete reference textbook. Then you can get the entire hierarchy. Okay. See, exceptions are of two types: checked exceptions and unchecked exceptions. Checked exceptions are checked by the compiler for the smooth execution at runtime. So these are the checked exceptions. Exception, interrupted IO exception, all these are checked exceptions. Next, unchecked exceptions are not checked by the compiler. Okay. Runtime, what are the unchecked exceptions? So runtime exception and all its subclasses are unchecked exceptions. Totally, there are only 18 unchecked exceptions in the entire exception hierarchy. Other than all these 18 unchecked exceptions, remaining all are checked exceptions. Here, remove this one. Okay, only runtime exception and all its subclasses are unchecked exceptions. Totally only 18 only. The remaining all are, other than these 18, the remaining all are checked exceptions. Here, remove this one. Checked. Okay, this is checked only. Next, error. Error is also one subclass of throwable. No? Error and all its subclasses are unchecked exceptions. So runtime exceptions and all its subclasses are unchecked exceptions, and also error and all its subclasses are unchecked exceptions. Except these two, the remaining all are checked only. Okay, next class I will explain the programs on checked and unchecked exceptions. Okay.